Labs. What are we going to do about labs? Fortunately, for the online environment, we have some resources at our disposal. In particular, the University of Colorado at Boulder has put out these beautiful simulations for science, including physics, that we can use. They did it in a grant from the National Science Foundation and other sources. So these simulations are provided for the community for free. And we're going to use those. I'm going to write the labs for these simulations that we are going to use in this course. It's the only part of this course I haven't finished yet, is writing all the labs for the course. But we'll have 7, possibly up to 10 labs for this course based on those simulations. They're free. But in order to see them, you also have to have the latest version of Java for your browser. And to get that, if we go into the lab folder of the Start Here folder for our orientation, there's a link in here called the Java download page. So you want to click on that, and it will automatically recognize what your browser is and find the latest download for Java for your browser. So in this case, it's update 65, but in later semesters, the update will be higher. But you'll click on this, download Java, and then you'll be ready to go with these simulations. Let's go back here. So then you'd be ready to try out this executable here. If I click on that, and as these go up, these are executables. So if they ask, if a computer asks, do you really want to open this file? And you're going to have to say yes. So you're going to have to trust these executables. And here's the one that we're looking at. This is Projectiles. This is actually lab number 2. And we can play around with this. You know, if I fire a projectile, I can watch a projectile go through a parabolic motion. Each one of these X's here represents 1 second of flight. So I got 1, 2, 3 seconds and a little bit more for this flight. I can change the angle of this cannon, shoot a different projectile. If I wish, I could change the speed over here. Let's just go 10 meters per second at an angle of 70 degrees. Try that. We'll fire that. And not enough oomph on that. 17 meters per second. We'll try 80 degrees or closer. So we can shoot projectiles all day. If I want to measure, say, range, I can take this tape measure, set up one cursor here and then the other cursor to where the other one intersects the horizon or intersects at the same level, and I can get a measurement of range, 25.05 meters there. Or if I want to measure the maximum height, I could set this up. Oops, I need my other cursor in there. Okay, so I could put this here and measure the maximum height, in this case 13.5 meters. So I can make these measurements just like I would in a real environment. Range, maximum height. I could change my pedestal here and shoot from a greater height and do that. Hopefully try to hit a target. Let's reduce this down. So, I'll move my target there, erase everything. So I'm going to fire, hit a target, score, and so we can have fun with these simulations. This is going to be part of the whole lab environment, is running these simulations. And what you need to do is to have a template to run these labs. And as we go into the lab folder, you will have that available to you. In other words, let's go into the labs here. And these are different labs. I got 2 of them here, but if I look at lab 2 here, I have a number of files here. The blue file is my main lab template. It's a Word file. If I click on that and I say OK, then I'm going to get a Word file that has everything I need to do with this lab, including questions and data that I have to collect or calculations I have to do. So I'm going to put all my data, all my answers, everything into this Word file as I go through the lab, including data here. I would just put in my data. I launched at 5 meters per second. I ended up getting a range of 10 meters. Maximum height was 7 meters, and so forth and so on. Put all this data into the tables. From time to time, I'm going to ask you to open a second file, which might be a Excel worksheet. Here, Excel Lab 2 worksheet. Now let's take a look at that. Let's see there. So that's this green file here. If I open that, I'll have tables, and I need to put my data in the tables, and sometimes they'll automatically do calculations for me. So, say if I put in my launch speed, my horizontal range, so forth and so on, maximum height, time of flight. These weren't good data because I have 10,300% error in my maximum height. So it wasn't good data. But once I get my data, I can save it here. I can click and drag over this table and do a Control-C to copy it. And I go back to my Word file. And if I find a space where I need to put it in, like in this empty space here, I click in that empty space. I can do a Control-V to paste my table into my Word file. And so there I have it. I can rearrange it here, just pull it in here, and my table's there. So great. And the other thing I might ask you to do is to take a screen save of your simulation as you see it. Let's go back to the simulation here. Let's say I did this and I want to prove that I actually scored, I actually hit the target. So I can do an Alt Print Screen on my keyboard, and that should do a screen copy of what I have there. And then as I go back into my Word file, I can click into some space and then do a paste, Control-V, and there's my screen of my scoring on the target. So I can do an Alt Print Screen to save it, do a screen save, and then Control-V to paste it into my document. So this will be my main document, answering all the questions, all these files. When I get to the conclusion, there are 4 things I need in my conclusion. First thing is to restate the purpose, which is the main objective of the lab. In this case, we set out to observe parabolic motion or projectile motion. Then state the main data in the lab that pertains to the purposes, actual main data values. So it might be like the range. We shot a bunch of projectiles and the range was 20 meters on one, 25 meters on the other. Theoretical value was 21 meters and 26 meters respectively. Then state the percent error on your main data. We got a percent error between the theoretical value of 2.3% from 21 to 22 meters or something like that. So you state the main purpose, state your main data that pertains to the purpose, and then your percent error on that main data. And then final thing that goes in the conclusion, state at least 3 sources of error that you can perceive in the experiment. These sources must be specific and must be intrinsic to the nature of the experiment. Like, we can only measure the range to 1 meter accuracy, so that probably contributed about 5% error or whatever. But do not state things like, there was human error and there was calculation error, and that's not specific enough. If there was human error, then you have to find out what the human error was involved with. Was it this measurement or that measurement or whatever it was? So I don't want you to take the easy way out on these sources of error. I want you to think about the experiment and come up with thoughtful answers as to what would contribute to error in this experiment. It could be the real world type of situation, or what in particular of this online experiment was contributing to your error. So that will be your 3 sources of error. Write that in the conclusion, put it right into this document. And when you're done with this document, you're ready to save it. save it as a PDF file. That's easy to send through a message. I don't want you to send it as a Word file. Send it as a PDF file. So save this document as a PDF file. And for your name of your document, put your last name, then first name, and then the lab number. So for me, it would be Golben John 02 for lab number 2. And then attach it as a attachment to a message and send it to me, John Golben, instructor, as a message email to me. And that would be your lab submission, and you would be done with that lab. So I'll grade it, give you a grade, and you're ready to do the next thing, possibly the next lab. So that's what's involved with the labs. Like I said, there will be at least 7 and up to 10 labs per semester. Submit those before the deadline. You can submit any time before the deadline, but up until midnight on that deadline. And we want to have a little bit of fun with this. These are fun simulations, and so have fun and give me feedback on that. It worked on trial runs, so I'm hoping it works for everybody in this course.